Hi, good afternoon, everyone. I'm Alex here. I'm the Senior Manager in Marketing from Swissmar Building Technology. And today, I would like to share with you my topic of the presentation of the customized metal roof systems to meet thermal and acoustic performance. So this will be the content of the rest of my slides and presentation. So topic one, we will probably introduce about ourselves here, Swissmar, who we are, what we do here. And topic two, we'll probably talk about the thermal resistance in regards to certain acts and Malaysia standards that the metal roof, how to address on the thermal resistance. And topic three, we will go to cover about the acoustic roof system, where the tools to measure the acoustic performance, like the STC rating, how to design a roof in regards to this STC rating. And then finally, we will have a method of roof installation. And here we will probably showcase you some of the installation of the standing seam system. So without further ado, we will go to introduction about the Swissmar as a company. So this is where we are as a company. Can we start the video? Can we start the company video?
Swissmar is Malaysia's leading roofing and cladding solutions provider. Over the years, it has grown leaps and bounds and firmly established Swissmar as a leading global supply and service provider. Through its relentless pursuit of technological innovations and advancements, Swissmar holds firm its steadfast commitment to providing total consumer satisfaction with effective service and customer care, offering everlasting returns on investments for all stakeholders. At Swissmar, we believe in materializing the world's structural visions with great integrity, employing the best of customized technology and manufacturing solutions which are fit for the communities of now and tomorrow. Thus, some of the most beautiful, long-lasting, iconic buildings across the Klang Valley carry our mark, including various infrastructure, industrial and commercial buildings, and upmarket residential units. At Swissmar, precision manufacturing is what we do best, and our work is also complemented by other services like architectural consultation, design engineering, research and development, and innovation to ensure we offer our best products and services to our customers. We received the Brand Laureate Award for 3 consecutive years and awards from one of Malaysia's largest Chinese dailies, Sinchu Daily.
We have to constantly adapt to the market needs, to what customer wants, and most importantly, we need to innovate.
Offering the best of steel as its raw material, BlueScope plays a key supporter in establishing Swissmar as a premier choice for the world's roofing and cladding solutions. Colorbond steel, made by BlueScope with proprietary Australian technology, is a true testament of time. Ultimate durability solution that meets international standards and performance expectation to ensure your iconic structures and its beauty are protected for a lifetime. At Swissmar, innovation lies at the heart of everything we do.
Well, thank you for staying tuned with us. And as a company, we chart our company direction to the total solution provider in metal roofing and cladding. And in terms of our service range, we provide the following. We do design of the roof system. We do have our own technical department to work hand in hand with the designer. And also we have our own manufacturing factory at Shah Alam. That's where we do all our standard and non-standard fabrication. And lastly, we also have our own project team to carry out the installation. So here is, we are like the one-stop center for your design. And in regards to the design of the roof system, we do cater for all this service, like the U value calculation for the thermal resistancy. So this is part of the service that we actually do provide to the architect and consultants. And apart from the U value calculation, we also offer the acoustic STC prediction report, and also the rainwater downpipe or the gutter sizings. So we plug in the number of the volume of the maximum rainfall and so on and forth. Then we will come up with the suitable, appropriate rainwater downpipe sizing and gutter. And also we have our shop drawings provisions to help the designer and architects. And also very important that we also customize all the metal roof system in regards to the statutory requirements, like to comply with the MS1525 or meeting up the U value compliance. So as for the material option, we are one of the company that provide the widest range of the options, ranging from coated steel product like the ColorBond steel, Zingalum steel, and to the non-ferrous product range like titanium, titanium zinc, copper, stainless steel, aluminium, and also a Sika Sanafil PVC membrane range. So in terms of the coated steel, we are a business strategy partnership with the NS BlueScope Malaysia. So we buy all our coated steel product from BlueScope Malaysia. And this is some of the product that feature in around the town, like for example, using the ColorBond steel featuring on the Otter Foundation Hall at Ampang, and the Link Kuala Lumpur using the Swissmar snap-up system for the entire colorful roof and wall cladding. And also for the non-ferrous product range, like we provide the aluminium for the Utah Grand Hall at Kampar, and Alamanda Shopping Mall at Putrajaya, and stainless steel product for the auditorium at Putrajaya using the Swissmar flat shingle system, and also copper with the pre-patinated pattern housing for the Sultan Aslan Shah Gallery at Perak, and titanium zinc for Dewan Petana at Kuala Lumpur, as well as another range of the Sika Sanafil membrane PVC membrane range, housing for the MyTech, one of the most iconic building around the town. This is pretty much about the customized roof solutions here. As you can see in the slides, that this is a very organic roof system. So this is actually a very customized system where the exterior, you look at it, it will be the aluminum composite cladding, and the Sanafil membrane, the PVC membrane, will be hide underneath the entire composite cladding, so serving as a waterproofing solution to the ACP panel. And IKEA Cheras also top of the roof is using a Sika Sanafil membrane roof. And as you can see, there's a lot of range of the so-called M&E penetration onto the roof with the smoke spill. So this perhaps the PVC membrane roof is one of the most flexible and good solution to address all the penetrations. And that is about the so-called service that we provide and who we are. And now I would like to move on to the topic 2. Here we will probably talk about the thermal resistance, particularly, in compliance to certain Malaysia standard and the X here, like MS1525, MS26880. Okay, so in Malaysia, I think most of our heat gain will be from the roof. So to design a roof system, a steel roof system particularly, you need to have a solution to address for its thermal comfort. so that it can bring you some energy savings. So we can actually customize our design to meet the best optimum of the performance in regards to address on the thermal performance. And one of the key element here to address for the heat is actually using the insulation. So the mesh insulation will be playing a key role to stop returning the heat. And the degree of the insulation is pretty much determined by the thermal resistance, or we call it the U value. So the lower the U value, the better your roof performance is in regards to return the heat. So for example, a U value of 0.4 watt per meter square will be much better than a 0.5 watt per meter square of the roof system. And in regards to the compliance of the bylaw and the standards, so this will be some of the range of the regulatory and the thermal resistant requirement, like for example, the MS1525, whereby it's clearly stated you need, for the metal roof, you need to comply to a U value of 0.4. And how about the Malaysia standard for the residential? There will be a building code of practice, for example, the MS2680. Okay, and also the uniform bylaw 38A. So to some states like Terengganu, Penang, and Selangor, this actually the building uniform bylaw is made compulsory for these 3 states to comply with all the metal roof design have to meet the U value of 0.4. Yes, so far these are the 3 states that are very advanced to achieve this. And to achieve the U value for the roof thermal resistancy, so what do we do here? We actually can use the software to actually tabulate all the roof components in regards to the insulation, the metal deck. So we key in and plug in the number given by the manufacturer, the declare of the R of the value, and so that we can come up with the total number of the U value here, so that it will have a prediction of what are the U value that we are talking about for the roof or the wall components. So, and here I would have 3 samples for you to have a look. And this number 1 here, sample here, I will show you probably a self-supporting metal roof system. This is a single roof system comply with the MS1525. So this is actually an isometric view of the single skin metal roof system. So here you will see there are numbers of the components complying here, which have the item 1 is a metal deck, typical metal deck, and item 3 will be insulation. Okay, and some of the sub elements like the subgird, item 4, and as well as the aluminum foil together. So if you look into a closer view of this, you will probably see a sectional that the metal deck will be on top of the topmost panels, and below the metal deck there will be insulations that packed in between the 85 mm thick, so that at the bottom here there will be a support of the aluminum foil as mentioned, and in item 4 here to support it. So with this system, it can actually help you to achieve a 0.39, which is slightly less than the 0.4 watt per meter square of the U value, which is complying to the MS1525. And for your information, this is one of the so-called economy way by using a single metal deck system to achieve the U value of 0.4. And I will take you the step-by-step sequence, see how the roof system is being constructed. So step 1, you will have the roof purlin designed by the engineer. We prefer the roof spacing for this purlin will be ideally at 1.2 meters center to center. Then next, we will come with the double-sided aluminum foil to lay over onto the purlins. And then third, you will have the top hat acting as an accessory to be fixed on top of the purlin. And you will have step 4, that the C channel as a subgird that actually bridging across all the top hat, forming as a solid rigid support to actually receive the insulation wool at step 5. So this is actually a mineral wool that thickness is about 100 mm thick with a 40 kg meter cube. We will tend to compress the height of the mineral wool into the 85 mm height. So the next step, you will see the final step of the metal deck panels, that how it receives onto the subgird and how it sits onto the top hat. So this will be the stack set will be the complete version of the single skin metal roof system. So I will share with you another system, the second example here for also a self-supporting metal roof system, which is a double skin roof system comply with the MS1525. All right. As compared to the previous example, perhaps here this is a double skin self-support roof system. Where I mean by the double skin is actually you have a two layer of metal deck. One is on the top, the other one will be at the bottom. So in between the insulation, we will incorporate inside between the top and the bottom deck. And if you take a cross section of this view here, you will clearly see that the top skin, which is item 1, and also the bottom skin, item 5, here is acting like a partition wall or the roof concept here, like a partition. And in between, we just infill with the insulation wool to, retard the heat transfer. And in this case, we will use a 16 kg meter cube fiberglass wool from the 100 mm thick compressed to 85 mm thick. And between there's a Z spacer or the top hat to space in between the top and bottom skin, so that this system will help to achieve a U value of 0.4 with a double skin. And the difference between the first and the second one is actually this example here as a double skin, you will see another layer of metal deck appear at the bottom. In fact, the first one, you will just see an aluminum foil, okay? So this will be a partition concept for the type 2. And this will be the coming slide to show you the step-by-step. As you can see, the roof berlin will be ideally like what we have mentioned at 1.2 meters center to center. And then we will lay the first layer of the underliner. We call it a metal deck, corrugated metal deck. And on top of the corrugated metal deck, we will input all the top hat here with the 85 mm height. And then we will start to lay the C-channel subgirds on top of the top hat. Then we will infill the wool in between the top hats area and to fill up all the gaps. So again, this mineral wool will be compressing from 100 mm to 85 mm height. And on top of the insulation, we will insert a layer of the double-sided aluminum foil. And this layer of foil is serving as a vapor barrier for the entire roof system. And finally, we will see the metal deck as a top skin to receive on top of the system. So this will be the step 7, the final step of the double skin and how it looks like. And the third example here I would like to share with you is a non-self-supporting metal roof system. When I talk about the non-self-supporting metal roof system, this is referring to a typical standing seam roof system. For example, this will be the isometric view of how the non-self-supporting roof system, particularly in the standing seam system that we are talking about. So you will see all the item ranging from item 1 to 9 here. So we will take a closer look of how the system is actually being composed together to meet the 0.4 U value requirement. So this is actually a typical cross-section blow up. So you will see there are more numbers of the roof components will come in. And as for the standing seam system here, we will use a noise damper to actually pack underneath the standing seam. And we will have another layer of the underliners, which is sitting direct underneath of the the noise damper item 2 here. And then after the underliner here, we will have a spacers like shown in the item 6 here, or the top hat. And then in between the space here, the purlin and the underliner, we will infill all the gap with the insulation, so that the insulation here is actually having a consistent thickness to address for the thermal resistant performance. Okay, so I will take you through the step-by-step method. And this is a step 1, as we recommend that the roof purlin will be ideally at 1.2 meter center to center. And then we will start to lay a double-sided aluminum foil at the bottom. Then third, we will have the top hat at 80 mm height. And then we will have the C-channel subgirt to run on top. And we will start to infill the wool insulation, particularly in the 100 mm thick and compressed to 80 mm height. Then we will start to have our first underliner as a metal deck to be sitting on top and the entire top hat area. And then we will start to put on the accessory like the metal strips here. And Swissmar foam here is acting as a separator between the underliner and the top layer of the standing seam. So this will be the full example of the non-self supporting roof system. Okay. And if you look into the mock-up samples here, so this will be the samples that you probably can refer. For example, the middle part here is showing you a self-supporting roof system, how it looks like. It's mostly a corrugated type. Okay, for the non-self-supporting roof system, like the last sample that we show here is a standing seam roof system, and here will be the typical mock-up that you can see how the insulation will come into the place to block the heat. Okay, so that will be the topic 2, that how the metal roof address to the thermal resistant requirement to meet the performance of the 0.4U. And the coming topic here, I will probably share with you about the acoustic roof system. So as for metal roof, the other major concern also will be with the noise. So how do you actually take care of the noise when you have a metal roof system? And so we can actually customize all the metal roof system to meet the acoustic requirement and also meet the acoustic comfort. So acoustic treatment is principally determined by the STC rating. And the higher the STC value, the better the roof is blocking the noise. So for example, the STC 45 will be having a better system than the STC 37. And how it works. So we will have an acoustic software. So this software is actually helping us to do the prediction. So how we do it is actually we key in all the design element of the roof components into the system. The software will help us to generate what are the STC, the likelihood of the range, the prediction will come up. So there you go with this. And to share with you how the acoustic actually function and what sort of differences, if roof with or without insulation, what will be the differences. So just take an example of here. Imagine that we have aircraft that flying on top of our roof now. The aircraft noise normally will be ranging like 90 dB, all right, very high frequency noise. So we have 4 example at the bottom here. So example 1 is actually a metal deck without any insulation. Example 2 will be a metal deck with some loose insulation. And 3 will be a metal deck encompasses with a good insulation. And the 4th sample here, the number 4 here, will be a metal deck with a lot of heavy insulation packed on top. So I will probably play you a voice over on this part here. So like for example, the aircraft noise after the 90 dB penetrate to the metal deck, which is having a STC 18 dB. the cutoff, so what will be the balance of the remaining noise into the indoor environment? Well, this will be the result that you will be probably hearing after the aircraft flying. Yeah. So this is without insulation treatment. Okay. Let's take a second example of the sample here. This is having a STC 31 system that to block the noise. So let's hear the indoor noise. Yes, probably you will hear a little bit more noise here, and the remaining sound transmitted into the indoor area is 60. So let's take a look into the third example here. What if we have a STC 41 roof system, you know, with the insulation blocking? What will be the noise like? Okay. Yeah, it's actually quite mild. It's something like the whispering noise. You can't really hear at all. And the last example I would like to share with you is this is a very serious heavy treatment of the STC 53. So by cutting out the STC 53 dB noise, this will be the remaining noise that penetrate into the room. So let's take a look and what we will hear like. Okay, this I play again. So you couldn't hear anything at all. So that will be the good range of the STC that we are talking about. So it's very important that you will have to design a metal roof with the insulation requirement that to meet a certain acoustic requirement. And the coming slides that I wanted to share with you is the sound performance indicator or the level comparison. So you look at the bar here, we are ranging from 10 dB to the 60 dB. So this is the likelihood of, you know, if you have a 10 dB is a very audible noise. The indoor environment, probably you will be like a studio recording, right? When you move up the number to 20 dB, that will be probably a library kind of a scenario or the environment. So it's a very quiet. And towards the residential home, what will be the dB that we are talking about? It could be close to the 40 dB range. So ideally, we will recommend that the roof system should be designed in STC 37 so that to cut off any 37 decibel noise from the outside. And if you move the bar up to the 50 dB, so this will be a moderate quiet environment where you can hear loud people talking. This probably will be like our open office area. And the 60 dB will be, you know, something like you entering to a busy restaurant. So it's very important that we know that what sort of the hearing range we wanted to have in the indoor environment. Like for example, the residential here, we will always recommend to have something close to 40 dB so that your roof system, you should cater to design for the STC 37 to cut off. So traffic outside noise will be ranging from 75, you know, that kind of dB. So after filtering the 37 of the roof system here, the balance of the decibel noise probably you can hear inside your house will be, you know, close to 40. So that will be the indicator sound level that I would like to share with you now. And here I will also want to share with you the three roof system, particularly with different STC design requirement. The first example here is a single skin metal roof system with the STC 34 system. This is a very nominal kind of a system to address for the acoustic. So probably you will end up with a single skin of the metal deck with the typical insulation pack underneath. And the second example here is a double skin metal roof system where acoustic design, you always will require a partition concept so that it will help to boost up your STC level to block the noise. So in this case here, the double skin will help you to block STC 36 noise. So this will be a better system that if you were to compare to the first sample. And the third sample here is actually a STC 45 system, where as the acoustic number goes up, so the more heavier the roof is. So in this case, beside we have the top and bottom skin as a double skin, we also incorporate a layer of the fiber cement board like item 6 here. This is actually some enhancement to really put in to block the noise from transmitting from the outside to the inside. So that's where your roof will be getting more and more heavier when the STC numbers goes up. So this will be the 3 typical example to address on the acoustic requirement, particularly in the STC rating. Yeah. So that will be the acoustic topic that we have come through. And coming topic that I will share with you, probably the method of the roof installation. So here I will actually show you some of the installation manual in regards to a standing seam roof system. Okay, so I would like to take this opportunity also to introduce you some of the standing seam roof that we have, like the SUSMA double work. This is actually, in fact, a non-self supporting roof system, where the roof panel itself have a very versatile profile with a double seam lock joints, offers you a very sleek and elegant appearance. For example, the top part of the standing seam roof system here, it actually is made out of the 2 sheets of metals that interlock together. Then we use a special tools to clamp it, to seam it. So after seaming it, it will be like, your canned drinks design on the top part. Is the same design concept that we plug it from here, apply it onto the rib of the rooftop here. So with that, it actually unlimited your roof application. This, in fact, is one of the system that I like most because it's so flexible. When you have a 3D convex design, this panel is actually very flexible. It can be tapered and curved anytime. And most importantly, it's also can allow to cater for the thermal expansion, and the panel itself is actually allowed for that. And with that, you also will enjoy leak-proof solutions, so that very importantly, in terms of architecture, it looks very neat and elegant, right? So this will be one of the samples of the non-self-supporting of the standing seam system, where, as I mentioned, a non-self-supporting roof system, you always require a solid rigid supports at the bottom. Okay, for example, this is the top part of the standing seam panels. So this panel itself, because it is so fragile, I would say, and very soft, and therefore when you subject to the human traffic, the panel itself will dent. Therefore, you will need a continuous rigid support like a metal deck here in this case to support it, so that you will have the so-called strength to actually cater for the human traffic. So the coming video, we will also share with you this typical miniature of the roof assembly system. All right. So before that, I would like to share with you also, these are some of the standing seam tools that special tools required to perform to do the seaming job. So this is the hand seaming tools that required to do the seaming. And these are some of the other range of the plier, cutters, and mallows, so that to perform the finishing work. So you will need to have this set of the tools so that to do the very craftsmanship of the work later. And not forgetting something like the small rubber mallet also. And here I will probably share with you some fabrication of the standing seam panels that we do here. So let's take a look. This is the roll forming machine for the setting sim panels. And when we insert the coin from the behind of the machines, when you roll out, it will become a male and female panels. So after finish the panel, we will actually do another process. We will bring the panels to another additional machines to do the chamfering. And in fact, this is actually one of our signature in our company that not many manufacturers, they have this so-called machine to perform the chamfering. So I would like to play the video here. And we input the rollout panel into this another dedicated machines to do the chamfering. Okay, so the machine will help you to do the automatically chamfer. And when you pull out the panel, you can see that the panels is already been chamfered. And next step, so we insert the same panel again into the same machines. So it will do the flattening effect here. Okay. And this is how we do the flattening effect with the same machines. And you will see that, you know, from a very sharp edge, we already flatten the panels. And the next step is actually the same machine again. You do the fold back. Okay. So this is actually the automatic machine that help us to do the folding back. And then you can see that the panels is already been fold back with this finish. This is the finished panels. So in summary, that additional steps or the machines that what they do the wonders is from step 1, they do the chamfering. After the panel roll out, they do the chamfering. Step 2, they do the flattening of this part. And step 3, they do the fold back. So that this is actually a very dedicated if folding of the if treatment of the panels. And step 5 here, I would like to share with you the install of the metal deck. First, we will install the underliner. So this is where, as I mentioned, the setting sim is a non-self supporting roof system. So therefore, you need a continuous rigid support at the bottom. So this will be the first layer of the metal deck to be installed as an underliner. And then step 6, we will have metal strips installation. This is accessories that we actually insert into the panels so that the strips actually install and it form as a flat surface to receive the clips on top. Okay, these strips will be repeated at every 600 interval. All right, this is how we do the accessory here. Then we will move on to step 7. This is where we start to lay the SUSMA form. This is a PE form that to actually have the acting as a separator and also noise damper for addressing the rain noise on the top panels. So this is how the form is been laid. All right. And then the step 8 here, we will have the if flashing installation. And now you will see after we install the P form, then we will start to install the if flashing. So always the flashing will be installed first. And you can see that how the if flashing is been hold and secure onto the underliner. Okay. And then here the step 9 will show you the final panel, how it received on the well-prepared substrate. So there you go. First, we will have the double wall panels on top of the SUSMA forms. All right. So properly tuck into the eave flashing here with a nice chamfering of the machine. Just now you saw how we do it. And then we will have to secure the panels with the stainless steel sliding clips. And this is actually sliding clips that can cater for the thermal movement. So you probably see a slot hole in the middle here of the sliding clips. That slot hole is actually to allow for the thermal movement. When the panel is subject to the heat, it will expand. So, the slot hole will allow the panel to slide through. Okay. And there are two types of the clips that been used for the standing seam panels here. This is a sliding clips type. And this sliding clips type, normally we will do it at every interval at the intermediate of the panels. When you move up the panels to the upper ridge or upper eave area, we will then start to use the different type of fixed clips to secure the panel permanently, so it won't allow it to expand at the very top part of the ridge part of the panels. So this is how the differential of the stainless steel fixed and sliding clips in between. And when we complete with this, we will start to have the seaming. So these are the hand tools required to use for the seaming. So we will do the single fold first, and then we will do the eave treatment with some rubber mallet here. And this is a very important steps that if you don't do it properly, the panel will leak, especially at the eave. So you will need to close up all the gaps with some very dedicated tools. And of course, you also require a very craftsmanship of the skillful person to know how to do all the seaming and the closing. So you will see the different of the set of the tools that required to do, and then the termination of the roof seam is been done. Okay, and you will then continue to do the single fold until the end of the panels. So this is the first seaming that you will see. All right. Then you will move on to the step 15. You use a double fold seaming with different tools to do up the panel seaming. Okay. At last, you will come to the eave closure with a dedicated eave closure seamers to do up the closing. Okay, there you go. This is how the panel is been fully secure and installed. And always use the right tools and the right method to do the installation for the standing seam panels. If you don't use the right tools or use the unskilled worker to do, this probably will be the disaster where you can see if the seam is actually been cracking. So if you use the right tools and skilled worker to perform the standing seam, it will become a very beautiful, sleek and elegant roof like this. Even like this, with a design of the change of the angles. Okay, here is another simplified version of the SWISMA double wall standing seam panels. We call it a SWISMA snap weld. It functions pretty much the same with the SWISMA double weld panels, except it is a click-on system rather than a double fold version. So this is actually to address for your model solution, especially for the residential markets, that you will require a quick and easy installation method. And very important, it offers the same sleek and elegant look as like the SWISMA double wall standing seam, the early slide you see. And also is a conceal fix system. And very important, it also brings you a complete leak-proof solution. So I will share with you some of the production of the panels here. So this is how we actually insert the coil behind the roll forming machine. This is a snap weld profile. So when the profile roll up, you will see the male and female panels for the rib here. And there you go. So after forming out the same approach that you will require to install the metal deck as an underliner, and then we will install the accessory like the metal strips on top. Well, if your eye is sharp enough, you probably will see that this metal strip is smaller as compared to the previous one. The previous one was a little bit wider because basically the wider of the previous one is to receive the stainless steel sliding clips. In this case, we don't really use any clips, sliding clips at all. It is screw-on panels that later you will see in the slide in the video that how this panel is being secured onto the strips. So then this is the installation of the SUSMA snap weld roof system. Compare side to side, side by side. I mean, this is a double weld standing seam, and actually it is very identical. It offers the same looks exactly like the SUSMA double weld. So you see how the panel is being secured with the fastener screw here, okay, without any sliding clips. This is much simple and easy. So when the next panel come in, it will interlock in between the male and female panels. And what you do here, instead of using the special tool to fold it, you will just need to press the male and female panel together. When you hear the click noise, it will be a properly secure panel. And then finally, you will perform the if closures with the same if closure tools that you have seen early on. So yes, then you will start questioning why we will need to do this, because this is a very simplified snap-on version of the panels. So it's unlike the double weld standing seam where you will have a dedicated machine to punch out for the chamfering effect. This, in fact, you will need to repeat every step, every rib at the side. So that will be the final of the version of the SUSMA snap weld roof installation. And this will be some of the end result that you can see, like for example, the link at KL with a very colorful color bond steel snap weld roof interlocked together with different colors. And we are coming to the very end part of our presentation. Probably I also take this opportunity to share with you some of the seaming type of the roof system. But in fact, this seam here is actually a typical corrugated roof system that we use a special seaming effect. This is one of our very deep corrugated metal roof system. We call it Suncor seam lock. And uniqueness of this profile is actually is a concealed fixed system, self-supporting roof system, but is using a seam-on method. Okay. So this is cater for this profile can actually cater for a very long length, like for example more than 100 meter. You know, that's easily can be achieved. The idea of this deep corrugation is actually best to address if you have any long length solution roof that you talk about. So with that long length, probably you will need a motorized seamer to help you. So this will be some of the video clip that you can see how the worker actually performing at the seaming at every rib of the profile. So it's a motorized seamer for a long length. Okay, and this is actually some of the production that you can see here. In fact, just now as I mentioned, this seam lock profile is actually one of the deep corrugation profile. So therefore, it can actually cater for a very long length. And to do that, most of the job required for this profile is having a on-site forming. So this is an on-site production that you can see that the machines is being placed on top of this platform, about the same level of the roof, so that the coin actually is putting at the back, and this is actually the entire machine. So we are physically bringing the production from the factory floor to the site here, so that the sheets from the back here, when go through the series of the roller of this roll forming machine, it come out with the profile sim lock that roll out. And you look at the number of the workers here stand how far apart to actually receive the final panels. All right. And this is one of the example of the on-site production. So this is actually captured in the area view with a video drone shooting. Here you can see the staging, how high the staging has been built up. And there's a standby crane full time to hoist the coin from the below to the uncoiler at the back here, so that it go through the series of the roller of the machines here to roll up into a one single length of the long length sim lock roof. So I will play video here to share with you. After the panels been rolled up, so the contractor actually designed a track system that to push from the roll up side on the right to the left. So because this is a sim lock system, is actually a male and female panels interlocking. So therefore you will have to start the installation from one end to the other end. And this is one of the, a very innovative way for the contractor to actually think of it, to shift, how to shift. This is probably talking about 98-meter length, how to shift the 98-meter length from this side to cross another side of the panels. And this is a final version of the roof system that you can see. Just now, the roof is actually, the roll on site one will be this entire roof here. You are seeing it. So this is housing for the Boston Scientific Manufacturing Hub at Penang, at Batu Kawan. And the profile will be the Suncor Simlock and in a carbon steel material. So with that, I will end my presentation here. And thank you for spending time with us. And do visit our Facebook and give us a like. And also, we welcome you to visit our SWISMA website, www.swisma.com. So please see us with the website here. So I will see you, catch up on the next session. Thank you. Bye.